What's up, 7th grade? Mr. Agnos here. This video is for homework 8-3. Excuse me. And in this video, we are going to start to solve two-step equations. All right? So just to take a trip down memory lane here, a couple of weeks ago, you guys worked on solving what were called one-step equations. And so I'll give 4 examples here really quick, right? X plus 5 equals 6. This is what we call a one-step addition equation. You know, you would subtract 5 from both sides. That's called the subtraction property of equality. If I subtract the same thing from both sides, I maintain that equality, and we would get x is equal to, remember these cancel, x is equal to 1. We also saw, what if we have subtraction instead of addition? So maybe I have y minus 2 is equal to 7. So remember, we talked about inverse operations. You're always doing the opposite of what's being done to your variable. So in the first example, we were adding 5, so I subtracted. In the second example, we're subtracting 2, so I'm going to add. I'm going to add 2 to both sides. That's called the addition property of equality. So again, you're always doing the opposite, right? So those cancel, and I get y is equal to 9. And then we also talked about, hey, what does this mean? Well, 9 is the only number in the whole universe that I can plug back in for y and have it make any sense. 9 minus 2 does equal 7, right? Any other number minus 2 does not equal 7. And then we also saw multiplication and division, right? For example, 3x is equal to 12. Well, since I'm multiplying x by 3, I'm going to go ahead and divide by 3. That's the opposite of multiplying, right? Subtracting was the opposite of adding here. Adding is the opposite of subtracting here. So dividing is the opposite of multiplying here. So those cancel, and I get x is equal to 4. And then we might have something like, excuse me, x over 5 is equal to 4, right? This means x divided by 5. And so the opposite of dividing by 5 is multiplying by 5. So I multiply the x by 5 and the 4 by 5. Notice how every single problem here, I'm doing the same thing to both sides of the equation. And we get x is equal to 20. All right, those were called one-step equations. And you guys seem pretty strong at those. Now what we're going to start looking at is two-step equations. These are all called one-step because it took one step to solve them. All right, I had to do one mathematical thing. Well, now, look at this equation they give me right here. 3x plus 5 is equal to 11. All right, this is the type of equation that we practiced writing last week. Now you actually have to solve it. And notice that, hey, here's my x. And there's actually two things being done to it. It is being multiplied by 3, and then we are adding 5. So that's one thing and a second thing. So that's why it's called a two-step, because there's two things that were being done to it. So to solve it, we have to undo both of those. Now, you may want to write this down, but when you're solving a two-step equation, right? I'll write it over here. And I'll talk about these algebra tiles here in a second. Step 1 is always undo addition or subtraction. So we're going to undo addition. That's always the first step. Undo addition or subtraction. Okay. In this situation, we are adding. We have this plus 5. So how do we get rid of adding 5? The same way we did for one steps. We're going to subtract 5 from both sides of the equation. Except this time we're not left with just an x, we're left with 3 x's. So I actually write 3x, right? If I add 5 and then take away 5, those cancel. And 11 minus 5 is 6. So that was the first step. But notice again, we're not, that's step 1. But notice we undid the addition. But notice I'm not done, right? I'm not done until I get a final answer of x equals something, right? We want to know think of x as a present. What is it, right? I took off the bow, but now I have to take off the wrapping paper. So how do I undo x being multiplied by 3? Well, just like last week, we're going to go ahead and, since we're multiplying by 3, we're going to divide by 3 on both sides. When I multiply and divide by the same number, they cancel, and I get x is equal to 6 divided by 3 is 2. And there's my answer. And notice that that took 2 steps. Here's the first step, and so that's step 1, and here was step 2. So over here, I should write step 2 is undo multiplication or division. So you can see in step 1, I undid the addition, and in step 2, I undid the multiplication. So let me do another quick example here of where I'll use subtraction and division. It's the same exact process. All right, so I'm just going to make up an equation here real quick. I'm going to say x divided by 5. I'm gonna see it. Minus 3 is equal to 1. Okay, so notice this time, look at step 1. It says undo addition or subtraction. Well, this time I'm subtracting, right? I have a minus 3 here. So step 1 says to undo it. So the way I undo subtraction is by adding 3 to both sides. And what am I left with? Well, I still have x divided by 5. So I take this whole puzzle piece here. I think of it as like a puzzle piece. I move it down here. If I subtract 3 and then add 3, those cancel. I bring down my equal sign, and 1 plus 3 is 4. So that was step 1. Okay, step 1 taken care of. Step 2, undo multiplication or division. Well, this time instead of multiplying, we're dividing. X divided by 5. So the way that I undo that is I multiply x by 5. Since x is being multiplied and divided by the same number, those cancel, and we get x is equal to 20. So my present this time is a 20. Right? So you can see how the process, whether it was addition and multiplication, subtraction, division, or any combination of these, is exactly the same. Now, what does it mean that the answer is 20? Well, 20 is the only number that you can plug back into our equation and get what we call a true statement. So 20 divided by 5 minus 3 should equal 1. Order of operations says we're going to do the division first. So I get 20 divided by 5 is 4, minus 3 is equal to 1, and that is true. All right, so 20 is the only number that would make this work. All right, let's talk about these algebra tiles real quick. Algebra tiles are a way of visually representing an equation. I never learned how to use these as a kid growing up or even in college. So here's what I'm going to tell you. If you are familiar with algebra tiles and you want to use these, you can. The basic idea is, all right, each of these little squares here represents like 1, and each of the big green blocks represents an x. So you can see that, hey, if this is an x, this is an x, and this is an x, well, there's my 3 x's. And then I have 1, 2, 3, 4, 5. There's my 5. Well, all of this stuff is equal to an 11. And I have 11 over here. And so the way that you would solve this is you say, okay, well, what if I get rid of, we undo addition or subtraction first, right? So what if I get rid of 5 from both sides? So I cross off this, cross off this, cross off this, cross off this, and cross off this. Well, whatever I do to one side, I have to do to the other. All right? So I'm going to get rid of 5 over here. 1, 2, 3, 4, 5. So now what am I left with? Well, I'm left with 3 x's and 1, 2, 3, 4, 5, 6. Right? So I have 6 yellow squares and 3 green rectangles, which means, right, that if I split these into 3 groups, that each x, I know I'm not explaining this well, each x is worth 2 of these, right? These 2 like belong to this guy, and these 2 belong to this guy, and these 2 right here would belong to this guy. And so what this does is it says, hey, well then each x is worth 2, right? And that is correct. You can see that 3 times 2 plus 5 equals 11, right? 6 plus 5 does equal 11. So again, you can tell that I'm not very familiar with algebra tiles, despite being a math teacher, but that's kind of how you use them. So if you want to use those as a visual tool, you can. All right, I'm going to skim through here real quick and just see what kind of problems I already skimmed through it earlier, but that one's got subtraction. All right. Anytime you add to both sides or you subtract from both sides, you're using what we call a property of equality. And they're all just named after whatever operation you're using. So when it says the subtraction property of equality, think about, how did I get from this step right here to this step right here? Well, if I have the 2-step equation, 3x plus 18 is equal to 30, remember, what we wrote down earlier was that step 1 is undo addition or subtraction. So I'm going to subtract 18 from both sides. That's what we call the subtraction property of equality. You're doing it to both sides, and so it's remaining equal, right? It's remaining equal. And that idea applies to all of them. If I add to both sides, it's the addition property of equality. If I divide on both sides, it's the division property of equality. And if I multiply, it's the multiplication property of equality. So that's all that these are referring to. Some of them you have to write the equation. So some of them, like question 5 here, you have to use the skills that we practiced last week, right? 4 times a number. That's going to be, in this case, they're using n. That's going to be 4n. Is decreased by 6. Right? What does decrease mean? It means we're going to subtract. So this is review from last week, except this week you actually have to solve it. Some more algebra tiles. Some more algebra tiles, and so on. Okay. Where am I? All right. These types of problems take a little practice. There is a rhythm to them, a pattern, right? Rewind to the beginning of the video and make sure you write down step 1, undo addition or subtraction. Whichever one you have, that's what you're going to undo first. Step 2, undo multiplication or division. I think of it as like a present. And if I'm going to give you a present, the first thing I do is wrap it in wrapping paper, and then I tie a bow around it, and I give it to you. Well, when you open it, you do what I did in the exact opposite order. The last thing that I did was tie the bow. The first thing that you're going to do is untie the bow. The first thing that I did was put it in wrapping paper. The last thing that you're going to do is unwrap the wrapping paper. So when you think about, 3x plus 5, the first thing that I'm doing is multiplying x by 3. That's the wrapping paper. And then I'm adding 5. That's the bow. And then I give it to you, and you're going to subtract 5. You're going to take off the bow. You're going to divide by 3 to take off the wrapping paper. So I'll talk more about that in class. Please, please, please ask lots of questions. Similar question is going to be your friend. The first time you see these, it'll be hard, and then by day 2 or even day 3, you'll get the rhythm, you'll get the patterns, the flow of it, and you'll feel a lot better. Remember, we're not supposed to get it perfectly the first time through, right? Okay, I look forward to all your questions in class, and I will see you guys soon.